Hello, everybody. Ooh, I have a setting I have to turn off. Uh, oh, okay. I think that's it. Now I gotta check my stream. Hello, everybody. Welcome to another Floaty Boat stream. We've been on kind of a programming kick lately, and I think we're going to continue with that because League of Legends don't really feel like playing recently. So yeah. I think what we're gonna do today is earlier, I think it was 2 days ago, we made this game called Cube Wars. And we made it in HTML and JavaScript, right? Now, some of you might be like, oh, well, web development is easy. And oh my gosh, like, I don't think you're a real programmer. If you write it in JavaScript or something, you should program it in a real language. Something like that. Or you could be a normal person and maybe just want like a higher frame rate for the game or something like that. So we're gonna basically recode Cube Wars using the same logic that we wrote 2 days ago, but we're gonna do it in Java today and kind of show you how to do game development in Java. Because it's really realistically very, very similar to all of this JavaScript stuff. It just has a bit of setup before we get here, right? So we are going to jump into that. In order to develop for Java, let's open Chrome. You're just gonna Google install Java, and you will see an Oracle link. Click the Oracle link, and then click on your operating system, and you can either do the MSI installer or the x64 installer. And then we're going to need an IDE in order to actually write Java code. So what you're going to do is go back to Google, and you're going to say Eclipse download for Java, just like this. And there's a link right here for the eclipse.org. You're going to click that. And there's a couple different versions that you can get. But this will work for us. Another version that you can get is Enterprise. And so if you do download Eclipse for Java Enterprise and you click this is another Java web developer, another Java IDE that is a different version of Eclipse. This is more for if you want to do like JSP programming and stuff too, but this will have more in Eclipse for you than just the Java Eclipse version, and I recommend this version more. So just look for the Java Enterprise Eclipse version, and you'll be good to follow along. And the Java one will work too for this one. We're not going to be going into any of the enterprise stuff today. But yeah, so that's all you need is just install Java and then install Eclipse. And when you first open Eclipse, it's going to ask you where you want your workspace to be. Your workspace is going to be where all of your project files are, and they're going to show up in your Project Explorer over here on the left. And so you're basically just saying, this is where I want my project files to be stored when you create a workspace. But yeah, I have this servers folder. You might not. That's okay. It doesn't really matter. We're going to right click in our Project Explorer. We're going to say new project. Then in this drop down, we have, let me scroll. Okay. Well, we have Java project here, or you can go under Java, and Java project is there too if it's not already here. But you're going to click one of those two, and you're going to give it a project name. So we're going to call it Cube Cube Wars. And then the default location is inside of my workspace, so we're good there. And then it's going to say use an execution environment. This is the version of Java that you are trying to build for. And Java 17 is what I have installed. And if you have a later version, that's fine. If you have an earlier version, that's fine. A lot of people develop for Java like 8 or 9. Those are some of the favorite versions of Java, but it doesn't really matter what version you pick so long as whoever's trying to run that program has that version or above installed on their system. So we could try and be super compatible, and we could go to 1.8, which is Java 8. It's kind of weird how they named it like this, but you see it goes down from 18 to 9, and then it's 1.8, 1.7, 1.6. All of these, you basically just ignore the beginning part. It's Java 8. You know, it's pretty strange that we did that, but it's whatever. We've been pumping out tons of Java versions in the last like 3 or 4 years. So as long as you're picking one that's compatible with your user base, you'll be good. And then I think this module thing is usually checked by default. We're not going to be using module info, so you can uncheck that if you want. I don't think it will affect anything if you leave it checked, but yeah, we'll go next. And we don't need to change anything here, so we're just going to say finish. And it says open the Java perspective. This perspective is designed to support Java development. It offers a package explorer type hierarchy. Basically, they want to change my window setup to be more like a Java developer usually has. And I'm going to say no, I don't want to change my perspective, my like windows in Eclipse, because I already kind of like how it is. So now if you click the arrow next to Cube Wars, you'll see there's a source folder. Let's open that. There's nothing in the source folder. And then the JRE system library, that's kind of like your installed version of Java for the project. And we're not going to be touching anything in here. We're only going to be touching what's inside of this source folder here. So let's right click the source folder. The first thing we're going to do is we're going to make a new, and we're going to say package. So a package is like a folder inside of your project. If you want to sort things into folders, you'll put them into packages. So I'm just going to say core. That's what I like to call my like main package that kind of starts everything off. And then we're going to right click that core package, say new, and we're going to make a new class. A class is kind of the basic Java file. Everything in Java is going to be made as part of a class. And if you're into like object-oriented programming, this is probably familiar to you. But we're just going to call this class main. And then I'm going to add the public static void main string args. And we will finish that. So here we go. This is our first file for our program. And they added a little comment here because it was automatically generated. We can delete that. But in any class file that you've made, any .java class file you've made, if you put public static void main string array args, this is the first function that will run when your program starts. So if you want to do anything in your Java program, it has to start here. So what are we going to do? Well, we don't really want to do much here. This is going to be in the command line. So let's just print something out to the command line real quick to just kind of show you how this works, right? Let's say hello world. So system is a like automatically imported library that you can access. It's going to give you access to a lot of things that have to do with your computer. And then out is the output stream to your console. So if you were running this in a console, then this is going to go out to that console. and we're going to print a line. Basically, we're writing some text, and that text is going to have a new line character at the end of it. So if we save this, we can click this little play button up here, and it will run our code. Now you see this is our console down here, and it says hello world. So we've successfully printed out hello world to our console. Before I forget, I'm going to start some music. That's probably chill. Go down just a little bit. Okay. I think we're good there. All right, so now we can do things with our program, right? We can run our program. Well, we want to make a window, and the window is going to be kind of like our Chrome browser. It's something to put our game inside of that has like an exit button, maximize button, minimize button, all that stuff, right? So let's right-click our source folder, and we're going to make a new package. I like sorting all of my graphical stuff into its own package. So I'm going to say GUI, and I'm going to save that. So now I have this GUI folder. Let's make a new class in there, and I'm going to call this mainframe. And the reason I'm calling it that is because a window in Java, as you would think of it on your computer, is called a JFrame. It's like a Java frame. We're making the frame of the window, right? So we're going to make this, and then we're going to say extends JFrame. And we'll push Control, Shift, and O. And that's automatically going to import that library to our file. Now, JavaX is a library, and inside of that library, we have Swing, which is another library. And Swing is going to be like all of your graphical stuff. And then inside of Swing, we have the JFrame class. And what we're doing is we're extending this JFrame. So when we extend a class, you can think of it as we are making another version of that class. It will do all the same things as that class. So essentially, we're making a JFrame by extending JFrame, right? And then we're going to need a constructor. How you make a constructor in Java is you just write the name of the class like that. And I believe you can say public like that too. I think that will work, but I believe by default they are public. So you don't really need to do that. And then this is underlined. If you hover over it, you can say add default serial version ID. This is something that a JFrame uses to kind of distinguish itself from other JFrames. And we can just set it to 1L. We're not going to use this anywhere. It doesn't really matter to us for this project, but if you want to get rid of that squiggly, you can put it in here. And so I'm going to put it in here because I don't like having underlines and stuff in my programs, right? So we can now instantiate the mainframe, right? So a JFrame has some functions that are already part of the JFrame class that we're going to take advantage of. So we're going to adjust some things of our frame. So let's say, first of all, set visible, and we're going to say true. And you can just write it like this. I prefer writing this dot set visible because that makes more sense to me. I don't have like some global set visible function like out here or whatever. Like this pertains to this JFrame, right? So we're going to set it visible. We also need to have another function here. We're going to say set default close operation, and we're going to set it to exit on close. So something interesting about JFrames is when you push the X that's up in the corner here, they don't actually end your program, they just become invisible. So if you want to actually exit your program when you're done running it, you have to have this line on your JFrame that will basically kill your program when you push the X button. So this line is very important, and this visible is also important. A JFrame is by default invisible. So you need to say become visible if you want to be able to see it. Then we also have a super function. This is calling the constructor of JFrame. So we're kind of copying a bit of the constructor of JFrame into our mainFrame class. And if you put a string in here, we'll say Cube Wars, then that will set the title of your window. So like how this says workspace, Cube Wars, blah, 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 Eclipse IDE. Instead of saying that, ours is going to say Cube Wars. Now, this is pretty good. I think we could actually maybe get this to run with a little bit of more code, and you could probably see the window. So we're going to go back to our main.java that we made in core that pretty much doesn't have anything in it. And let's do a swing utilities dot invoke later, and we're gonna do a lambda here. So swing utilities is another library we have to import that's part of Swing. So it has to do with our graphics, right? Because I said Swing is our graphics library. So we're going to say invoke later. Now, what does that mean? Well, unlike JavaScript, or some people call it ECMAScript, even though that'd be technically wrong because ECMAScript is a standard and JavaScript is a language. But anyway, we're splitting hairs, right? So JavaScript is a single-threaded programming language. It can only do one thing at a time, right? Java doesn't have that limitation. You can make, let's say, a thread is a new thread. And when you, oh, I don't even have to import thread. That's interesting. But anyway, like as you can see from the coloring, thread is a class in Java. We can make more threads. So we can do things simultaneously. We don't have to wait for one thing to complete to do another thing. Because let's say like you have multiple processors on your computer, you can give one processor one task and the other processor a different task, and they'll both do them at the same time. So I have to explain threads like that and explain that this is a multi-threaded language because Swing, our graphical interface that we're using, has its own thread. And in the thread, you can kind of think of it like an array, right? We'll say there's an array. I'm going to say like draw the character or something like that. And then we'll do like move the window and then like make the character red or something like that, right? And the reason why I'm writing it like this is I want to explain to you that this is how the Swing Utilities thread works. Every time you ask the Swing Utilities thread to do something by saying Swing Utilities invoke later and putting a lambda, anything you put in here is going to be like draw character. So when you do that, it's going to push whatever you told it to do onto the end of this array. And it's going to process everything in this swing thread from whatever entered first to whatever entered last. So if you queue this up really fast, it's probably going to lag and it's not going to do everything as soon as you told it to. But it is the proper way to use the Swing class like Swing library is that you ask Swing to queue up whatever you want to do, and then you allow it to do it. And this is generally pretty fast. It's kind of difficult to like overload the Swing utilities, like invoke later stuff, like to make this array too long. It's pretty difficult, at least if you're using Swing kind of as intended. Swing was made to allow you to make things like forms, and games weren't exactly the focus of Java. You can make them in Java, but it wasn't the original intention, essentially. So, at least with this graphics library, you could bring in some other kind of graphical interface in order to, have higher FPS, whatever. Anyway, we're not going to do that. We're going to do straight vanilla, raw Java code in order to make our game, because I don't like importing other things. I think you should know how to do everything from your basic installation to get to where you want to get to, instead of relying on more dependencies that you have to download. So anyway, now that we've kind of explained this, so our drawing to the screen, like making our window and everything, is all going to happen in this Swing utilities thread. And then all of our processing, let's kind of look at this. So like all of our, where is it? All of our render stuff that we put in here where we're drawing to the canvas, all that stuff is going to happen inside of our Swing utilities thread. And then all of the processing collisions, shooting bullets, all that stuff, all that's going to happen, like everything that's in our update essentially is going to happen in its own thread. So they're going to work at the same time and they'll work together. So now that I've kind of explained that, I hope I explained it well enough. Let's move forward. So here, we're going to invoke later something. Well, we could say like new mainframe, something like this, right? Right, and we'll just import that with Control-Shift-O. And now you see from our GUI package, it's importing mainframe. But the constructor is not visible because we don't have public. So by default, it is private. We've discovered that. So I could do this, and this will create one instance of our mainframe. But we don't really plan on making more mainframes. And if we make mainframe this way, it's kind of difficult to pass the mainframe around to all of the files that need a reference to mainframe. So what we're going to do is we're going to make something called a singleton. So what a singleton is we have this class, and a class is used to make instances, right? Well, then you need a reference to all of these instances you're making and pass them all around, whatever. What if I told you you can make a class, and the class itself can be like a static instance, and you can access that instance from anywhere outside of the class? And you might be like, oh, but what about like the security vulnerabilities of that? No, Okay, I'm just gonna tell you, right? If someone already knows how your code works, like if they can read your code, and they already have a way to like decompile it to do that or whatever, it doesn't matter what security you're putting in place, like they're gonna get around it. So like, first of all, who cares? Second of all, this is just a simple game we're making. So we're just going to make it in a simple way that's easy for everyone to understand, and they can all develop it in a way they like. Sup, Semph? It's good to see you. I hope I'm not too loud. I took a filter off my mic. I'll see you around later. All right, man. Sounds good. Just doing some programming stuff. Just banding tools on Unkick. Alright, so what we're going to do is we're going to make this singleton that I'm talking about. We're going to make this class into a singleton. How are we going to do that? Well, we're going to make a private static. Static means it is specific to this class. It doesn't have anything to do with instances of this class you make. It's specifically tied to the class itself. And then we're going to say mainFrame. And you're like, wait a minute, but we're making an instance of the class. You said we were only making one instance. Like, you'll kind of see where this is going. We're going to say instance. Now, here is where I like to put this function. We're going to say public static. So again, this function is going to be publicly accessible from anywhere. And it's static, so it's specifically tied to this class itself, right? And then we're going to say mainFrame. And this is the type that's going to be returned. And we're going to say get instance. All right. Now it's going to say we're not returning anything, so it's kind of mad right now. We're going to fix that. So first of all, we're going to say return instance. So that's cool. Anytime we say mainFrame dot get instance, it's going to return this instance variable. But this instance variable isn't set to anything yet. So we're going to say if instance is null, instance equals new mainFrame. And you can like new line this, or you can surround it in braces to make it like easier for some people to understand, you know, something like that. But now what's going to happen? Now, when we say mainFrame dot get instance, it's going to say is instance null? Well, it hasn't been set to anything yet. So yes, it is null. So then it's going to say, okay, well, make instance into a new mainFrame. So we're going to make a new instance that's going to run this constructor. And now we have an instance of this mainFrame, right? And then we're going to return that instance to whatever was calling the getInstance function. So now we have access to this private field from outside of this class just by calling this class name.getInstance, right? But then the next time we call getInstance, it's going to say if instance is null, which it isn't, because we've already turned it into a mainFrame instance, right? So it's going to skip this, and it's going to give us the instance that already exists. So if you write this way, now from anywhere you call getInstance, it will create an instance of mainFrame, and from then on, anytime you ask this for an instance, it will give you the same instance that you made the first time you ran the function. This is a really simple, easy way to kind of cheat how Java is like laid out to make it so you can access like static variables from anywhere. And I really like this. I think it allows you a lot of flexibility to be able to manipulate like one thing if you're not going to make more instances of it. And particularly for Windows, I enjoy doing singletons because I don't like having like multiple settings windows or like multiple drawing windows or whatever, right? Like you only need one of those for a game. So now that we have this getInstance set up, instead of saying new mainFrame, why don't we say mainFrame dot getInstance? Because this is going to create an instance of mainFrame, and that's going to create Like that's going to instantiate this instance to not be null anymore. So any future times we call this, it's not going to be null anymore. It'll return something we've already made. And that's going to start up our window because it's a JFrame. And it'll make the window have Cube Wars as the title. It has a default close operation and we'll set it visible, right? So now I believe we can run this. And when we run it, we get this tiny window in the corner. I'm going to make it bigger. Ooh, this is rough. Okay, I'm going to resize it. This is exactly what we were looking for. We made a window. Its title is Cube Wars. And we have our maximize, our minimize, and our, oh, where'd it go? And our exit button. And when we push exit, you'll notice this stop button here is going to go away. See? Now our program's no longer running because we exited the window. And that's thanks to this line here. If we push the exit button, it closes the window. If we did not have this, it's not the end of the world while we're developing the program. But if you're running this outside of your IDE, I'm going to lower the mic just a little bit. I think I'm like peaking. So if you left this commented or out, like after you've given the game to someone outside of the IDE, then when they go to run it, they're still going to get something similar, right? They're going to get this window. But then when they close it, you notice this stop button is still here, meaning our program is still running. You just can't see it. So we're going to terminate that because we're still in our IDE. We can do that, right? So that's cool. That's cool. And then let's say you wrote this, but you didn't say set visible, right? This is the other issue I want to show you. You click run. I don't see anything. And it looks like it automatically terminated the program because none of the windows were visible. But there is a possibility that this would just be an invisible window in the background and it wouldn't close. So we want to be able to see it and we want to be able to close it. So that's why we have these two here. All right, now we have a window. We want, for one, we want the window to be in the center of the screen when it starts. So we can do a property on this. We're going to say this dot set set location relative to, and we're going to say null. I believe you can put like a dimension in here or something to specifically say where you want the window on the screen. But if you say null, it will default to the center of your screen. So if we run this now, you notice the window starts in the center of our screen. And we can resize it, and there we go. So it's not starting top left anymore, it's starting in the center of our screen, which is what we wanted. And then we need to be able to put something inside of our window, right? Similar to, I don't know why this isn't working. Similar to how we had to make a canvas inside of our browser, we also need to make something inside of our window in order to be able to draw on the window, okay? And what we're going to make is we're going to make a J panel. A J panel, the way we're going to use it, is going to work the same way a canvas does. Normally, a J panel is used to draw like buttons and things like J buttons or J text fields or whatever you want. Like I said, it's meant more for forms. We're going to kind of override how that works so that we can draw to it instead of putting buttons and things on it. So we're going to right click on GUI. We're going to say new class. And what do we want to call this? We can call it like canvas or something, but there is technically already a Java class called Canvas in a different library. It's in the AWT library. But we don't want to name something the same as something that already exists, right? So let's think about what we want this to be called. Well, we called this main frame. What if we just called this main panel? I think that's pretty decent, right? Because it's a J panel, so we'll include the name panel, and then main because it's going inside of our main frame. I think that makes sense. So now we're gonna extends JPanel instead of JFrame, and we'll import that. And then again, we'll hover over here, say default serial version. Like I said, we're not going to be using this, so it doesn't really matter if you don't have it. I believe it'll still run no matter what. And then we're going to make our constructor here. Cool. Now we have a panel. This panel is not already on our window though. So we need to add this panel. Well, once again, I don't want to make one instance of this. I want to be able to access a single instance from anywhere. So we're once again going to turn this into a singleton that I explained earlier. So then we're just going to say public static main panel, get instance. And I write these a lot because I really like singletons. If instance is null, then instance equals new main panel. Okay. And I usually write it like this. It's a bit more consolidated because you're not doing that extra brace. An if statement will only contain the next line if it doesn't have braces. So that's why this works. Or you could put it like that as well. That also works because it's only the next thing after the if statement and then it would return. But I think that looks a little bit messier. So I'm going to do it like this. All right, now we have a way of getting our main panel from anywhere. So we're going to say, we could say jpanel, jpanel panel is main panel dot get instance or something like that, right? We could do that, and then we'd have to import jpanel because we're instantiating one in this class. But I don't want to import jpanel, so I'm not going to import it just yet. But we have a function on our JFrame to add things into the JFrame. So we're going to say add, and you can say this dot add if you want, which I prefer. And then we could say panel here, and it would add this JPanel into our JFrame. But I'm going to shorten this. I'm just going to cut this out and put it in here, because we're already returning the JPanel with this function. And so we're going to add whatever JPanel that is into our JFrame. Now, when we run this, it's not going to look any different, right? Because we haven't done anything with the panel, but it is there. And the way that like panels and things work in Java inside of a JFrame is they will stretch to fit as big a space as they possibly can. So the JPanel is fully filling this window right now. You just can't see it. Well, how are we going to make sure that that's what it's doing? How about on the panel, we can say this dot set background, and we can say color dot black, and that automatically imported this Java AWT color class. This color class is an easy way to define new colors that you want to use in your program. And it has some defaults that you see, like black, or we could do like blue or white. It has all of these different colors defined, And you can see all of them in your IDE by just writing color dot, and then you can scroll down. So you see there's like magenta, light gray, all this stuff, right? But we're gonna go with black for now because it's very apparent that would be different from what we have. So let's run the program. Let's stretch this. Now our entire inside of our frame is black, right? That's because our panel is black. And the panel is stretching to fit the entire inside of our frame. So that's exactly what we want. Let's close this. Now, I'm tired of resizing this window, right? So let's give it a size. Well, the frame itself is not what I want to resize. I actually want to resize the inside. I want to resize this panel, and then I want the frame to adjust its size to be the size of the panel as well. And the reason for that is because the frame's size doesn't account for your title bar. So if I said this was like 900 pixels high, then it's actually 900 pixels inside minus whatever your title bar height is, and we don't want that. We want 900 inside plus whatever the title bar is. And depending on your operating system or operating system version or whatever, this title bar size can change. So we don't really know how big this title bar is going to be. So instead of sizing the frame itself, which is going to include this title bar in our size, we're going to resize the panel. In order to do that, we're going to say this dot set preferred size. And then in here, it's going to take a dimension. What is a dimension? Well, a dimension is just something with a width and height, really. It's just a 2D way of describing something. So we're going to say new dimension. And we're going to say this is 900 by 600. Because, and we're going to import dimension with Control-Shift-O. Because this is the size of the canvas that we made in something that I can't pull up easily because Windows sucks. This is the width and height we set of our canvas in our previous video, right? Our previous stream 2 days ago. So we're going to try and mimic this game as much as we can. So we're going to set it to 900 by 600 to match that. Now, if we play this, you'll notice it didn't actually resize, but we told it to resize, right? Well, we resized the panel. Now we need to resize the frame to match the size of everything that's inside of it. In order to do that, after you've added everything you're adding to it, you need to pack the frame. And pack is just going to snug up to everything inside of that frame, which is going to resize the frame. Now if we run it, boom, you see we are in the center of the screen. We're 900 by 600 inside of the frame, and then the frame adjusted its size around that, which is exactly what we're looking for. And I will say, the order that you do these in can matter. And so let's say like if we change the location of it before we pack it and then we run it, now it's not in the center of the screen anymore. That's because it's positioning it as if it were this size, right? But it's not that size. It's supposed to be like this size. So we need to make sure it is the size that we want it to be before we position it. Now, setting it visible should probably come last because we know we need to set all these variables up for it before we want the user to see it, right? And then this default close operation, you could probably move this around. You could probably put this anywhere in here and it would still work. I just like putting it at the bottom. But the order you do these two matters, and this one for like user experience, I would put it at the last, right? So now we have this panel. Instead of black, I think we'll do white. And the reason for that is because here we made the background of our canvas white. So we want to match that, right? So we run it, the background is white now. So our canvas is white, it's ready to be drawn on or whatever, right? So what we need to do now is we need a way that we can draw on this panel as if it were a canvas, right? Well, JPanel has a function in it that we're going to override. So we're going to say @override, and that's just a little note pretty much telling ourselves that we're overriding something from JPanel. And this is public void paint component, I believe. And this takes in a graphics object called G, and we'll open it like that. And then we're going to have to import this graphics library. So now that we've imported this paint component function is called whenever the Swing library tries to update what we're looking at. So when you first make your window, it's going to call this, and it's going to do whatever's inside. Now we still want it to do what it would normally do if we added like buttons and things to it. So we're going to say super dot paint component graphics G, I believe. This may be wrong. I might have to change this later, but we'll try it out and see. So this is calling the JPanel class's paint component function and doing the same drawing things that it normally should do before we're going to do our stuff, right? So what do we do now? It does the same thing it used to do. Well, we have this graphics G object. So let's type G dot and see what it can do. Well, we see here there's a clear rect. That looks familiar, doesn't it? If we pull up our JavaScript one and we scroll down to render, where all of our graphics stuff is happening, you see can.clearRect, right? This is exactly the same thing and works exactly the same way in Java as it does in JavaScript. But instead of can, we're writing G. And you can actually change this can to be G by changing our reference to the context to be let G equals canvas.getContext2D. Or vice versa, you could come in here and you could call this can and can, and then you could say can.clearRect, fillRect, all that stuff, right? But G is kind of the standard for Java, so we're going to use G. We're going to say G dot clearRect 0, 0. We're going to say get width and get height. And you can say this dot get height and this dot get width as well. So you know you're specifically talking about this panel, right? And this is the equivalent of us saying canvas.offset width and canvas.offset height. It's the same thing. We're getting the pixel width and pixel height of our canvas, or in this example, our JPanel, right? So now we're clearing from 0, 0, which is the top left. As we discussed earlier, Y is reversed in graphics programming. So top left, 0, 0, this width, and this height. So all of the window is going to get cleared, right? Then let's do a g.fillRect and it's trying to help me. It's not being helpful. We're going to say 15, 15, 100, 100, something like that, okay? Now when we run our program, boom, we've drawn a square exactly the same way as we would have done it in JavaScript on an HTML canvas, right? So you might already be starting to think, hey, this is like kind of the same difficulty as doing it in JavaScript, right? Yeah. Anyone who thinks like C++, Java, all of these like lower level languages have to be more difficult than like a scripting language is wrong. Like there's obviously more things that lower level languages can access, and some of those things they can access are perhaps more difficult to work with, but that doesn't mean that the language itself is really more difficult, at least in my opinion. So now that we have this, we have our square. Well, we know our player was a different color, right? So let's change the color. G dot set color, color dot blue is the color our character was, right? So this is how you change the color. The same way you would say fill style in JavaScript. So fill style is set color, which I believe I accidentally typed when I was doing the first stream of Cube Wars. So now you know why I typed set color instead of fill style, because I haven't been working with JavaScript much. I've been more in Java. So now that we can do this, let's we know we can draw, but we're only drawing once, right? So how are we going to make it so this keeps redrawing? Well, that's where our other thread is going to come in. So in, let's maybe put it in core. Let's say new class, and we're going to call this game. And we're going to finish, okay? Now, game, we're gonna implement something called runnable, and we're gonna not import. We're gonna add unimplemented methods, okay? And all it's gonna do is add this @override run function. So what does implementing runnable do? Well, runnable is an interface, which essentially means it's some functions that we plan on using across multiple classes. And the function that's inside of the runnable class is this run function. So it's just an easy way to add a run function to many things, right? But there's some things that are specifically looking for something that's implemented by runnable in order for us to use the class the way that we desire. And so we're gonna kind of explain that in a second. Let's make game another singleton because we just love singletons. So private static game instance and public static game get instance. Because once again, there's only ever going to be one game instance. We're not going to make more of them, and we just want to be able to access it easier, right? So if instance is null, then instance is a new game, and then we're going to return instance. Okay, now it's a singleton. Awesome. Let us kind of see what we can do with this, right? So this run function isn't being called anywhere, so it's not actually going to do anything, right? So let's go back to main, where we started our window. So we're going to make our window first, just to kind of get that started and out of the way. And then we should probably do this after. let's make a thread. We're gonna call this game thread is a new thread. Okay? So we're making our second thread. We've already made our graphical thread. We're gonna make our processing thread, right? And then inside here, we can say game.getInstance. And it's actually okay with that. But thread would normally take something called a runnable, right? But wait a minute. We implemented runnable on game, right? Which means that our game instance is a runnable. So our game instance is going to be what is going to run in this new thread, okay? So we've also used get instance, so it's going to be the singleton instance we're creating. And so we'll be able to access that instance from elsewhere, right? Okay. Well, technically, we don't need to name this thread. We can just say new thread like this. And now that we've made this thread, well, it doesn't just start. It doesn't start running immediately. So what we're going to do is we're going to add dot start. And that will start the thread running. So we've got this one running. Now we've got this one running. And what does starting the thread do? Starting the thread is going to look at this runnable, and inside of that runnable, there's a run function, and starting that runnable is going to run the run function. So now this is going to run automatically when we start our program. So let's try that out. System out println I am running quietly or something like that, right? Because we're not going to see this doing anything. It's just going to run in the background. So let's run this. And you see, I am running quietly. It's the little ninja in the shadows, just doing its thing without anyone noticing, right? But we also got our window because we have our graphics thread that is also running. Fantastic. The character's blue, so we've changed the color properly. I'm pretty sure we haven't run it since we did that. So now you see all of this stuff is working as expected, right? We close it, the program terminates because we said the exit button terminates our program. That's what that did. So that's even going to kill this background thread that we have running, right? So what are we going to do with this? Well, first of all, we want a game loop, something that's going to keep updating our data forever until we kill the program, right? And that's what our set interval here was doing for the JavaScript, right? Well, we don't really have set interval in Java, unfortunately. So we kind of have to make that ourselves. So what we're going to do is we're going to say while, and we can just say while true. Normally you would say like while a game is running or something like that. And so we could make like a private or public, which depends on what you want to do. You could say like private boolean running is true by default. And then we could say while this is running, then do this, right? This would work too. I don't really care to ever stop the game. Well, do I not? Do I not? We do need a way that we can like restart the game. But I don't think we'll stop the game entirely to do that, the way we wrote it in JavaScript. So we're just going to say while true. This is how you would pause your game if you wanted to as well, is you could say the game is no longer running, so it wouldn't update like positions and things, and so your graphics would keep updating, but nothing's moving or doing anything. So it's like the world is asleep. And that's how you like pause your game. But we're not going to allow pausing the game. We didn't in JavaScript. We're not going to in Java because we're just remaking the same game, right? So there's a couple things we need to get into here. So we need kind of a timer system. So we're going to say private, we're going to say past time or last time or something like that. We're going to set that to 0. And this is going to be a long. Time, as we're going to measure it in milliseconds, is going to be managed as a long. So we're going to make kind of a placeholder here that's the past time, and then we're going to say private long current time, and we're going to set that to 0 too. And then we might need something called like delta time. We'll kind of look into that in a second. But we'll run it like this for now, and we'll see if we run into issues. So while true, basically forever, we want to keep doing this stuff, right? So we're going to say the past time is equal to the current time, and you'll see why in a second. And then the current time is equal to system.currentTime millis. So Millis is a good neighbor of mine. She likes keeping track of time, a lot like the god Kronos. And so anytime I need to know what time it is, I yell across the street to Millis, and she'll tell me what time it is. I'm kidding. Millis is short for milliseconds. Why we don't write the whole word, I don't know. Because I don't think it'd be too many more letters. Maybe just current time or something would be nice. Like current time whatever. We shortened it to millis. So this is the current time on your system in milliseconds. Since like an epoch or something. For discussion. Anyway. Oh, returns. The difference measured in milliseconds between the current time and midnight, January 1st, 1970, which is the epoch. So it's the amount of milliseconds since this day, and your system just always keeps track of that. So it's, we're getting a measurement in milliseconds of what the current time is. So we're setting our current time to that. And then we're going to say if the current time is greater than or equal to the past time, wait. Let me think. No. We're gonna subtract the past time. If that's greater than or equal to 1000 milliseconds divided by 60, then we're going to do something. So why are we laying it out like this? Well, the current time is what time it is right now, right? And that's measured in milliseconds. The past time is going to measure what the current time was last time we went through this loop. And we haven't set that yet, but that'll be like here. So we'll say past time. Well, it's kind of already set here. So we have set it, I suppose. So the past time is going to become the current time, which is the previous time. The current time is going to become the current time. So then our current time minus the previous time is the time it's been since the last time this function ran. And when that's greater than 1000 milliseconds divided by 60, which is 60th of a second, we're trying to make 60 frames per second. You might understand where I'm going with this now. Then we're going to do whatever's in here. Well, we want to draw our panel 60 times per second, right? That's kind of the idea. So we're going to say main panel dot redraw. Is that not what it's called? We do have to import it from GUI. Oh, we need main panel dot get instance dot redraw repaint. Yes, it's repaint. So the instance of main panel has a function called repaint. And what that's going to do is it's going to call our paint component function again, which paints all of our stuff, right? So that means 60 times per second, we're going to repaint what's on our main panel. And that's exactly what we're looking for, right? We're going to try to add this to our swing utilities thread from our processing thread, and we're going to see if that lags or not. And we will notice that a bit later, but let me think about this for a minute, because we might only want to set the pass time if this happens. So we need the pass time to be the current time. I think this does need to be in here, because we always want to check the current time, but we're mostly managing the pass time to say the last time we updated a frame. So I believe that this is correct. But something that I'm noticing now as well is we don't want to paint once every 60 seconds. We want to paint whenever we can. So we're going to put this down here, and we're going to update our game logic 60 times per second, which is really what we're updating with our set interval is our game data. So we may put both of those things limited by frame rate at some point, but because we're in Java, we can separate these update and render into two different things, like two different threads, and we can process them at different rates, right? So we're gonna try and draw as often as we can because it's just in a while true. And then we're gonna update the game data once every 60 seconds. And then we're gonna run into an issue that I'm going to come back and fix later to show you kind of a problem with how we're managing this. But we need to update the game data here, right? So we're just going to say this.update. And then down here, we're going to make a public update. And this is just going to be a void, which means it doesn't return anything. It's just going to be a void function here. So now, every 60th of a second, this update function is going to get called, right? So we're calling update every 60th of a second, and we're painting to our panel as often as we can. That's awesome. Let's kind of give this a try. Let's say system out print line. We're just going to say hello, and let's run this. All right, you see hello is being printed like a ton of times per second, right? And we're just scrolling and scrolling and scrolling down here. That's because we're printing hello 60 times per second. So let's try to kill the program. And we can clear the console. So our loop appears to be working. And the repaint doesn't seem to be making any major issues at the moment. We'll leave it as it is. Now we need to get into some of the game logic we made, right? So what do we want to do with our game objects? Let's maybe make some, let's make a package here. What do we want to call it though? Like game objects, maybe something like that. Um, I don't want to call it objects because that's kind of generic. You know, you can make a lot of different kind of objects. Let's call them like world objects or something like that. Okay. And I'm gonna do a single just world object because that's the kind of standard I like. I'll say world object dot something and it'll be whatever that world object is. We're gonna say new class and this is gonna be our player. So now we have this player object. We're gonna make a constructor for it. And this is a Pojo, or a plain old Java object. And we're gonna mimic how we designed the player in here. So here we have an X position, a Y position, width, height, X velocity, all this stuff, right? So we're just gonna copy this and we will paste all this stuff here. Now, it's obviously not written correctly because this isn't how you write it in Java. So we're gonna say this equals that, and this is gonna be a double. And we don't have access to our canvas here. What if we did, we don't really have a good way to get this number here. So what if we just say, well, we know our canvas is 900 in width. We were dividing that by 2, and then we were subtracting the characters width. And the reason that we can't do the canvas stuff is because as soon as we run the program, it's immediately going to try to evaluate all these values. And we don't actually have a canvas right when the program starts. We have it after we've run this mainframe get instance function. So we can't just statically add this stuff in here. We could, however, if we want to be a bit tricky, we could say, we could make some public static values in this main panel. So let's say public static, and we could say final as well. That means it's never going to be changed. And we're gonna say dimension, and we're gonna say something like size, something like that. There's a new dimension, and we're gonna say this is 900, 600, okay? Now what we can do is instead of saying new dimension here, we can just say size. We should probably change the name of this. We'll say like default size, something like that. And all caps is just kind of a standard for things that are final because you're never going to change it. So if it's all caps, you should be scared of it and not touch it. Pretty much anyway. So we'll say that. And what that does is these are going to immediately be added to our program when it starts too, because this is a property of this class, right? So now in player, we could say main panel dot default size, and then we don't want the width and height, we just want the width, right? So let's say dot get width. And that will give us our width of our canvas or panel, whatever you want to call it. And then we can divide that by 2. So it's a bit longer than what we wrote in JavaScript. Just a little bit, but it will do the same thing. Now we can do the same thing here, but with the height, right? Nice. And then we need to make this a double, and it's equals. Okay, and each of these need to be ended in a semicolon instead of a comma. And it's angry for some reason. I don't know why. Who knows? It'll probably fix itself in a minute. So then we can say like int width. We don't really plan on like dividing the width of our character or anything. So we're just gonna leave int and int for height. And then our velocities, we know that we have things like gravity that was a fraction, right? It was a decimal. So that's why we have double on our x and y position, is we need to be able to account for decimal places. And an integer doesn't have decimal places, but a double does. So we're going to use double for these as well. Double, double, equals, equals, semicolon, semicolon. Okay. Now jump velocity. This was a constant that we made. We're not going to adjust the jump velocity, so we can make that into an integer. And then speed was also a constant. We're not going to change our speed. So we're going to make it an int. This was a Boolean. This was a Boolean. This was a Boolean. And this is equal to that, this is equal to that, this is equal to that, and then these should all be semicolons. It's just kind of a language conversion that we're doing right now. Now, color blue, the reason this was here is because in here we wanted in our render to change the fill style to be blue, right? But that's written a little bit different in Java. We were using the color class for this and set color on our thing, right? So let's kind of change this. Let's make this a color, and we're just gonna say color. That's fine. And instead of a string, let's say color dot, and we'll say blue. Okay, so now we have a color instead of a string that will be the color blue, but let's make it all caps. I prefer writing it in all caps. And then all of these were booleans. Boolean, 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 boolean. And that's equal to that, equal to that, equal to that, equal to that. And these are semicolons. Okay, we've successfully done a language conversion. So now we have all these settings for our player. That's awesome. Did we do anything when we made the player? Let's look at that. The player doesn't appear to have had a constructor. So let's just delete this constructor. We don't appear to need it, right? So now we have the same setup as what we had in JavaScript. Now we have the player. Awesome. Let us, let's think about this for a minute. Again, we're only gonna have one player, right? We're not gonna make multiple players. So what if we made this a singleton? I just love singletons. Private static, and we're gonna say player instance public static player get instance if, this is not a function, if instance is null, then instance equals new player, return instance. It's not a function. Okay, now player is an instance, which means we're only going to have one of it, right? Which essentially allows us to access players similarly to how we made this object in JavaScript. So that's great. Let's draw the player to the screen. I believe we can do that now, right? So let's say, instead of setting the color here, how about we say player.getInstance dot, what did we call it? We may need to make these public because I believe the default is private. Let's say these are all public. And normally it'd be better practice to make these all private and then have a getter and setter for them all. I don't really want to do that. Right now, we're just mimicking how we wrote it in JavaScript. So we'll just make them all public. Now if we go back here, we can say getInstance.color. And that's going to take the blue from our player class and put it as our draw color. Now we were filling player getInstance.x, right? Player dot getInstance.y. And then we'll break this to the next line. Player getInstance.width and player getInstance.height, right? So this is the same thing as us drawing the player in our render function here. So we were drawing the player's x, y, width, and height. We're drawing the player's x, y, width, and height. But we have a little red line under here. The reason for this is because pixels are only measured in integers. But our player's x and y position, we've defined as doubles. So we need to get these from being a double to being an integer somehow. There's a couple different ways you can do it. You can do math.round, and you could do that in a way that doesn't replace everything that you have. And that will make it into an integer. And that is going to say, like, if it's 5.5, it'll round it to 6. If it's 5.3, it'll round it to 5. It doesn't really matter too much what we do here. If anything, we're going to be 1 pixel off. I personally prefer just casting this to an integer, which means you put some parentheses and you say int. Now this is going to become an integer. I believe casting it is just going to chop off whatever decimal places there are. So if it's 5.7, it'll be 5. If it's 5.3, it'll be 5. I believe that's how casting it to an integer will work. It's the same thing as saying, like we had that round function, there's also something called floor. And floor is always going to round it down. So I believe this will have the same impact, but I don't want to use math and write all that stuff. I just want to do a quick int here, and it will accomplish the same goal. And that's on our x, but we're still underlined because our y is also a double. So let's just turn that into an integer as well. And that makes our underline go away. So now we have all these variables set up. Let's try and run the game. And we have the player positioned not down here, which is interesting, but it is in the center. So we probably have the width correct. We just don't have the height correct. Let's go take a look at that and see why that might be. Also, my game is like freezing. So we're gonna have to, we're gonna think about this. I think queuing this up is causing some lag in our game. Let's just try to repaint it like this. This is not the proper way of doing it, but this might allow our game to run faster. So our Y, we said was the default size, the height divided by 2 minus 50 minus 50. This might not be the same thing that we wrote in here. We said for the player, it was the full height minus 50 minus 50. So instead of dividing by 2, we're going to do the full height minus 50 minus 50. We're going to try this again. Okay, that looks like where it should be. And when I close, it's actually not lagging anymore. So we're going to leave this as it is, even though technically this is not the proper way to use the swing class. We're going to use it this way. We're kind of abusing the library a little bit doing it this way, but it's going to work. So we're going to do this. Yeah, so we have the player positioned and colored, and he has all of these properties. So we're gonna run it, and I'm gonna let you just look at what we have so far while I take a bathroom break. But if you're like following along and you have this, that's fantastic. If you're just reading along and like watching along with the tutorial, that's cool too, man. Just know you're gonna sit here for a second. So I will be back in just a second. All right. I think I gave you enough of a break. Are you ready to start drowning in code again? 'Cause I am. Okay, so we made the player, and that's cool. Let's make the grass as well. So let's make a new world object. We're gonna call it grass, right? And then we're gonna refer to what we made before. Grass. This was our properties. Let's paste them in here. So grass, we could probably make these into integers, but I think we'll leave them as doubles because I like managing all of my location data as doubles. But the width and height can both be integers because we're not going to be changing those. And then again, instead of a string, we're going to make color into a color, right? And it was green. So color.green. We're going to maximize that because I like how it looks more. And then we'll import the color class equals semicolon. Okay, and then same thing. We're gonna need to get the canvas height and stuff. Let's grab it from here. We'll put it in here. That's the canvas height, and then we need the width, which is this one. Okay, it is unhappy. Oh, we have to make this into a double because we're doing some math with it. Ugh. I know, how about we just make them all doubles? We'll make the width and height of everything into a double. Because this is a smaller game, we're not really concerned about memory management all that much. But that will mean that we will need to cast these to be integers in our render function. So now they're all integers when we're trying to draw them, but while we're processing them, they will be doubles. And that's chill. We just converted the grass over. That's exactly what we wanted. So let's go back to our main panel, which is our canvas. And then where did we draw the grass? We drew the grass last. So similarly to how the canvas works, the last thing drawn on the panel is going to be the thing on top of everything else. So if I drew the enemy after the player, the enemy would overlap the player. If I draw the grass after the enemy, then the grass will overlap the enemy and the player. So we're going to say G set color. Oh, but we forgot something. In order to access the player's stuff, we had to make it into a singleton. Let's go. Let's make grass into a singleton. Private static grass instance public static grass get instance, and then if instance is null, then we're going to say instance is a new grass, and then we're going to return instance. Fantastic. Now we can access our grass publicly too. And we, now that I said the word public, also need to make these public so that we can see them from outside of the object itself. So we're going to go back here. We're going to say set color. We're going to set it to be grass.getInstance.color. Forgetting that get instance part is a very common thing you'll run into, and you might run around in circles being like, why can't I see color? I made it public. oh my gosh, you know, all that stuff. It's chill. It happens all the time. Like just relax, take a step away. You'll come back and you'll find it. So we're gonna say fill rect, and then it's trying to help us, but it's not helping. We need grass.getInstance.x, grass.getInstance.y, and then we're gonna wrap it grass.getInstance.width and grass.getInstance.height. We need a dot here. And then it's angry because they're all doubles. So we're going to cast them all to integers again. And now it's happy. Okay, so we know this is the grass. We know this is the player. And then here we're just clearing the screen. So I'm actually going to move it up like this to make it a bit easier to understand that it's doing that. Okay, so now when we run, boom, we have our grass and we have our player. You might notice some of the colors might be a little bit different. That's because our color class, saying like green or blue or whatever, like we're saying here, that's something defined by the language that you're writing in. So when I say blue in Java, it doesn't necessarily mean it's the same blue as if I write it in JavaScript, right? So instead of, let's say, green, can we find like a dark green? It doesn't really look like it, does it? There's a green. But I don't see like a darker green. So what are we gonna do about that? Well, if you want to make your own colors that aren't already defined, you can make a new color. And inside of here, I believe you can do, let's just look at it real quick. It appears you can do RGB values. I think there's a way you might be able to do hexadecimal, but you might need to make like a conversion function between the two. I don't know, you know, I just work here. So we're gonna go with RGB, and R stands for red, so we don't want any red. G stands for green. Well, we want a lot of green, right? We'll write 255. 255 is the maximum amount of a color that you can have. It's between 0 and 255. So we're going to have all of the green we can possibly have. And then the B in RGB is blue. So we don't want any blue either, right? And now we've made this new color. It's no red, all green, no blue. It should be green, right? So let's take a look at that. It appears to be exactly the same color as the default defined green. Well, we want to make it a little bit darker. So how are we going to do that? If we remove some green, it's actually going to make this darker. So let's maybe try like 150, something like that. Let's try that out. Okay, it's a little bit darker. I don't know how much darker we want to make this. Maybe like a little bit darker. Let's try like 125. Okay, that looks pretty nice to me. You know, it kind of looks grass colored. So we're gonna go with that for now. That's cool, but you might notice while you're looking at the screen, I'm pushing WASD and nothing's happening, right? We don't have any way to control our player yet, and we would like to do that before we add the enemy in, right? Because if we can't control the player, we're just gonna die in like 2 seconds as soon as the game starts. So let's take a look into that. So the GUI, or like our window, is going to be what listens for our keystrokes. It's kind of like how here we said our document was listening for these keys, right? Well, our frame, like I said, is kind of our replacement for the document, right? Or like our browser window. So we're gonna say like frame dot on key down. Well, there's kind of something that goes in the middle in Java, okay? We don't automatically have these listening functions on the frame. We have to make them kind of ourselves. They're sort of made already, but we just have to like uncover them in a way. So let's go to GUI and we'll say new class. And we're gonna call this oh, what do we wanna, we could call it like keyboard listener or controller, like controls listener, something like that, something along those lines. Maybe like input listener or something like that. I don't know though, that might exist in Java. We don't want to do keyboard listener because I believe that's what we're going to be implementing. We'll just do controls listener. Something like that. Okay, we have this, and then we're going to implement something called key, I think it's key listener. And we're going to import that. So that is the correct class. And then you'll see this is underlined, right? I'm going to change my music real quick. But after I do that, we'll continue with this. Where's my custom playlist? This one. All right. It's played the same song in like 10 different remixes. So I'm kind of done with it. All right. Now we're back. This is underlined, right? If you hover over it, it will also say add unimplemented methods. Similar to how when we implemented the runnable interface, this is also an interface called key listener. And when we click that, boom, it's gonna spit out 3 functions for us here. And we can kind of truncate it a bit, get rid of these comments that it made for us. But if we look at the names of these, you see key typed, that doesn't really look too familiar, but key pressed and key released. That's a lot. It sounds a lot like on key down would be like on key pressed or key pressed or something, and on key up would be the key released, right? That sounds really, really familiar. So we don't know anything about this key typed one. We're gonna cut this and we're gonna shove it on the bottom. We're not gonna worry about that. What key typed is if you push the key down and release it within like a second. If you do both the down and up within like a second, it will fire this function. But we're not gonna be doing that. But we still need this because you do need to override every function of what you're implementing. So it needs to be here, but it doesn't need to do anything. That's why we're leaving it empty. So that's cool, that's cool. We have all this stuff, but technically we haven't added this controls listener to our window yet. So we're gonna go to our main frame, and similar to how we added our panel to it, we're gonna say this dot add key listener. Now that sounds familiar, doesn't it? And we can either say new controls listener, or what's my favorite thing in Java again? Oh, I know. Singletons. Isn't that awesome? We love singletons here. So I'm gonna say private static controls listener instance. And we probably are not going to really access this from anywhere else, but I would like the ability to, just in case. So we're going to say public static controls listener get instance. I'm glad I caught that. If instance is null, then this is not how I like to write it. Then instance equals new controls listener. And return instance. Okay, now it's a singleton. Now we can access it from anywhere. So we're going to go back to mainframe. And instead of saying new controls listener, we're going to say controls listener dot get instance. Same thing, we're just changing how we're accessing it, right? So that it'll be the same instance no matter where we're calling it from. Cool. Now, we have the ability to listen to controls when we push keys now, right? So there's this key event E. What is that? Well, if we look at our other game, we also had an E here. And this E is where we got the key code for what buttons we were pushing, right? So what if we just say E and we say dot? What does it say? Oh, consume. That's interesting. I believe if you consume it, it makes it not do anything. So let's look at what other things we can do. We say get key char. Okay, that's interesting. That seems like from reading this to be similar to that thing that I showed you in the console, where you can get either the uppercase or lowercase a, depending on whether you're holding shift or not. And again, we don't really want that because I don't want the game to not work if you accidentally have caps lock on or if you're holding shift or something. I want it to always work when you push the key, right? Well, the next one we see is get key code. Now that sounds like something we want, right? So we're gonna do that, and that sounds a lot like the key code. Well, what if we try the same numbers that we did here, but in Java? Wouldn't that be interesting? So let's say if e.get key code is equal to, and we'll say 87. How about that? 87. Then we want to say system out print line. We're gonna say W pressed, right? Because 87 was our W key. And when we push it down, then we should be pushing the W key, right? Let's try that. Let's run it. And so long as you're focused on the window, I can type whatever keys I want. It's not going to do anything. But when I push W, oh. Now, how come this number is the same between Java and JavaScript? Well, that's because this number comes from essentially your operating system. So no matter what, because we're on Windows, the W key is going to be translated as 87. So it doesn't matter what language it is, W is always 87. Now, what does that mean? Well, that means we can just copy all this and we can paste it in here, can't we? But there's red lines. Okay, sounds like we need to do some translation, right? So e dot get key code, and it is a function. So we're gonna replace all of these with that. And then player isn't just player, it's player dot get instance dot jump. And this is misspelled. Okay, now we're accessing the player in the Java way, right? So let's copy this. We will just paste it here, paste it here, paste it here, paste it here. There appears to have been some kind of indentation problem with how we pasted this in. So let's try and fix this in some weird way that doesn't appear to be working. We have spaces in here. Cringe, cringe. Who wrote this program? Cringe. Boom, boom, boom. These are all like indented differently. Okay. And then that's for our function. So let's indent all this one and indent it again because it's inside of the function. Then we'll indent each of these. All right. You don't really need to fix the indentation stuff, but I'm pretty picky about it. So then player.getInstance.reload. Now, what was this? Because it doesn't appear to be working, right? If we look here, it says location.reload. So it's not even the player that's doing it. We were reloading the page, right? And this was when we pushed the R key. Now, this isn't going to work for us because we don't have a browser. We have a window that we made, right? And you can't just refresh a window the same way you can refresh a browser. So we're going to have to think about that and possibly implement that later, right? So we're going to just comment this all out, actually, because we don't want it listening for this if it's not going to do anything. And we'll just say reload, just like that. Okay, so we've converted all of the button presses that we do now, though, right? So let's do the let's do on key up now. And that goes in key released. And then we're gonna have to fix the indentation, unfortunately. I believe that is good. Indent, 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 indent. Okay. Now we have to do the language conversion. So get key code instead of just key code, and it is a function. So we're going to copy this. We're going to paste it here. We're going to paste it here, paste it here. And then instead of just player, we need player get instance. And now all of our button listening should work, which is fantastic. So we added the controls. We're now toggling things, and we should be able to move and stuff. But we don't have any of the actual game logic that's running in the game yet. So we have things like gravity, and we have this update function where we're doing all of these things, but we're not doing any of this yet. So even if we can change values and like increment and decrement things, we're not actually updating any of that in the game. So we need to go to where we're updating the game, and we need to remake some of these, which would be in game under update, where we're updating the game, right? So what's the first thing we're doing? We're making bullets. Well, let's not worry about that yet. We can't even move the player. So let's say player dot xvel, right? Equals 0. But again, it's player get instance, not just player. So we're going to change how that's written. Let's change yvel to be 0, and that's setting our initial x and y velocities. And then we have update positions. Let's go see what's in there. Update positions. Here it is. We have the player jumping and moving left and right. This is all the player stuff. So let's paste this in here so we can do some things with the player, right? We're going to say player. And instead of just player, it's player.getInstance. So let's replace all of these with that. And it appears to be fixing our indentation when we paste, which is cool. Now there's also gravity. We made gravity as kind of a global variable, sort of, didn't we? Yeah, it's just like off on its own. So there's two kind of things we could do. We could make gravity part of the player, because the player is the only thing affected by gravity. Or we could also make it a local thing to the instance of this class, which I think we will do to kind of stay consistent with our language conversion. So we're going to say private. It's going to be a double because it has a decimal place. And we're going to call it gravity. And that was equal to 0. Which is interesting. So we set it equal to 0. Now it's underlined because we're not using it yet, but that doesn't matter. We will use it in a second, right? So we can now probably move left and right. I don't think we're being affected by gravity though. So let's go back to our update. Update positions. That's probably part of this. Update positions. Enemy, bullets, the player left and right. We're just changing whether you're jumping or not. So I believe we've already handled all the player stuff in update positions. So update positions is done. Okay, here we go. Now we're managing gravity here. So let's copy this, and we need to add it after these if statements, which we need to unindent this, which is going to be a whole mess. But in the end, it will look nice. So we're going to fix this. Okay, so we need to indent all of this to be that if statement. And then I think we might have deleted a brace by accident. This will all be in here. These are all in there. Oh, no, we didn't. We're good. It's like this, right? just the first bit is the if statement. It's here. Yeah, just the first bit has 2 if statements. And then after that, which means we could actually rewrite this a little bit too. We could cut this and say and that. And then we can cut these out, which I think I was going to do, but I forgot. So anyway, now we've just kind of simplified that. It's the same thing, so should still be good. And then here we're adjusting gravity and the player's velocity. So let's fix the indentation. Gravity's fine as it is. We could say this dot gravity, which would be a little bit different, but it doesn't really make a difference. And then player, we know, is player get instance instead of just player. And that appears to work, right? So when we start the game, hold on, I want to make sure there's nothing else too crazy here. Nope. I was looking at the wrong thing. We have player X is all okay. So we need to update the player's X position in accordance with their velocity. That's one thing that we're forgetting here. Okay. So now the player should fully function properly, right? Let's take a look. He's gone. Where'd he go? The answer is we're falling, but we're not stopping when we hit the ground or when we hit the edge of the screen. So we're just falling. We're somewhere way down here because we don't have any collisions. So let's take a look at those collisions and see if we can get those added in, right? So let's say process collisions. It was after we did this. So we're going to process collisions here. And we can just make another function here. We can even make it private. We're going to call it process collisions. We're making it private because we're not going to call it from anywhere else. And this is just going to be a void. We just want to do this. We don't want to return anything, right? So let's go look at our collisions. Well, we said if the player is greater than the height of the grass, then we're just going to set it equal to the grass's height, pretty much. So let's adjust this, get the indentation right. I think it was right to begin with. And then we're going to replace, again, player with player instance. And instead of grass, we need grass.getInstance, right? And then I believe it deleted. Yeah, it's y here. So grass.getInstance dot y is what we wanted. And we're going to copy this and replace grass with that. All our problems appear to be resolved. So let us try and run the game again and see what happens. We're standing on top of the grass. So it appears that our collisions are working. Let's try and move left and right. All right, that appears to be working. Let's jump. Awesome. So we have all of our player movement that we originally had in the other game now, because we have the key listeners on the window, we have the update loop that's running, and we have the collisions that stop us from falling through the ground, which is awesome. And I'm actually surprised I'm not seeing a rendering issue that I usually have. But one thing that can happen is if we're looking at the game loop here, what can happen is our update can take an amount of time, right? Because we do this check, but we do this check before we do all of this logic. So then we want to know how long it took us to run all of this code, right? So I usually make like a delta time is what I call it. I'm going to call it delta time. We're going to set that equal to 0. Now delta time is going to be the amount of time it takes to run all of this logic. So we're going to say delta time equals, now we're going to check the system current time milliseconds, and we're going to subtract what our current time is, because current time was what we checked before we did all of this logic, right? And then we're going to say past time is equal to the current time, but now we have this updated delta time. Well, when we're doing this check, I actually want to add delta time to this, because delta time, the amount of time it took for us to get through this work, is going to impact what our current time distance was. And so if we add delta time here, it's actually going to run this loop almost exactly 60 times per second, if I remember how to write this correctly. So you probably didn't notice it before because I have a good enough computer, but now this animation and stuff should be so much smoother with this delta time. Without the delta time, you might skip some frames here and there. But with the delta time, it's almost exactly 60 times per second. So it's great that we see that. Like we don't see it, but you know, that should fix that problem if you're having that problem. So that's why I mentioned delta time earlier, is it's important that we have it. And the delta time, if you're making like a networked game where you're playing with other people, it's very, very, very important that you are all on the same update clock, because your update clock affects things like how fast you can move, right? It's also going to affect how often you can do actions, like if you push a button to like chop down a tree or something. Then if your friend's loop is going faster than yours because you don't have this delta time, then your friend is going to be able to chop that tree before you do. So if you're like in a competition and you're both trying to chop down as many trees as possible, your friend's going to be able to chop down more trees than you because his loop is running faster than yours. And that's due to his computer being built better than yours. So just kind of a hardware constraint that we're trying to compensate for here, because some people are going to take longer to run this update than other people. And you'll see delta time and things like Godot if you use that. There's some other game engines that also use it, but they give the delta time control to the developer, and you have to manage all that stuff. If you manage delta time this way, you basically never have to worry about it again. Just pretend everything is running at 60 frames per second, and you don't have to worry about like frame rate and all that nonsense that they have in Godot and stuff. So that fixes our drawing issues if you were having any. We weren't, which is cool, but it is what it is. So now we have our game. We can move around, we can jump, we have collisions with the grass. We can currently run off the screen. That was another collision we had set up, right? So let's go back to our process collisions. And we had player screen bounds. This is what we want to lock the player into the screen. So we're going to add some comments again. This was your collisions with the grass. This is the player screen bounds. And we're going to do some language conversion. Player, 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 player. And then the canvas offset width, well, we can go to player to find that. that was main panel default size get width. So we are gonna go and replace all of this with that and all of this with that. Now it's a bit longer, but it's the same logic that we used in our other stream. So I don't feel like breaking it and making it easier to see or anything. But now when we run, we should collide with the edge of the screen. And we do. And we can't jump over it or anything like that. We're locked into the screen just as we wanted, which is fantastic. So what now? Well, now that we can move and we're not going to fall off of the screen, how about we make bullets? How about that? Go in kind of the same route we did before. So we need to be able to make bullets. Well, we know in JavaScript, we made this bullet constructor just completely off on its own. It doesn't have its own class or anything. That's not something that we can do in Java. We have to have a class for everything. So we're going to make a class for bullet instead of just a function. And we're going to make that in world object. So class, we're going to call it bullet. And then now that we have a class for it, we can make a constructor, right? And like I said, this is basically just a constructor outside of a class. So we're just going to take this and we're going to put this inside of the bullets constructor, and it's going to serve the same purpose. But we need to make some local variables so that we can store this per instance of a bullet. So we're going to say double X, and we're just going to leave it blank. Double Y, double width, double height, double xvel, double, we don't have a yvel. We have a boolean that is alive. Okay, so now xvel equals xvel. So we don't have our parameters, so let's get those parameters, right? Let's put them into the constructor. This is going to be a double. This is going to be a double. And xvel is going to be a double. All right, it looks like everything's great. Let's make these public. Again, you'd normally make them private and give them some getters and setters, but I'm trying to keep this simple and show that if you're not worried about like security and stuff, that this is a very quick way you can convert from like JavaScript to Java. But this is perfect. This does exactly the same thing that our bullet function does, is if we make a new bullet, we give it some parameters, and then those will have those values. This does exactly the same thing. And for once, we're going to be making multiple bullets, right? This is a class we're going to make multiple things of. So we are not going to do my favorite thing and make this class a singleton. We're not going to do that. So that's cool. Now we have this constructor. We also had this array here called bullets that was just like all of the bullets that were in the world. Well, we know gravity was kind of a global thing for the world, so why don't we make this also a global thing for the world? So we're going to go to game. We'll go up to where we made gravity, and we're going to make a private array list. You could also say list. I like writing array list because I don't like following conventions all the time. And we're gonna say bullets equals array list. And then we need some of these like diamond shapes. And what you put inside of these diamond shapes is what you're gonna contain in your array. So we're gonna say we're gonna contain bullets in here. And if we import everything, then this appears to all work, maybe. There's something up with this. It doesn't like invalid name. There is a way that you can write this. Oh, it's because it's not a new array list is what we need. Okay, so now that's all situated. We don't need to put bullet into this diamond because it's going to grab it from here and it already knows it's a bullet. It's just to save us some time typing. We could also write bullet here and that would also work, but I'm just going to delete it because it's going to implicitly know that it's going to be a bullet list. And an array list is pretty much the same thing as an array in JavaScript. There's a few differences. The main difference is it can only hold one kind of data type. So if I made this like an integer like this, then I could only put integer numbers in this array. But we want to put bullets in this array. So we're going to say only bullets can go in this array. Other than that, pretty much the same thing as a JavaScript array. So don't think about it too much. We'll just kind of move forward from here. And this is underlined because we haven't used it yet. So now we have the ability to make bullets, and we have a list to put the bullets in. Maybe let's look at the process bullets that's in our update and see if that will get us to make some. So let's make the process bullets function again. And we're gonna say private void process bullets so that it matches, right? So now let's go to process bullets. This is all of the logic that we had in that function. So let's put that in again. And we're gonna try to fix some of the indentation. And these are spaces. I cry in programmer. Let's indent these. This is all inside of this, I believe. It will indent these. Okay, the indentation should be better. Yeah, this is all inside the first one. Yeah, we're good. So again, as always, player isn't just player. It's player.getInstance is the full way to write player in Java. And we're gonna just keep replacing player everywhere we see it. Let's replace this one first so it doesn't scroll. And we will work our way through here like this. And we can like new line these so we know this is all part of kind of the same thing. And we'll close it off like this. Okay, that's pretty good. So you'll notice push is underlined. It's not push when it's a Java array or array list, whatever you want to call it. It's let's say dot push. It's not push. It's I believe it's put. If I'm remembering correctly, I'm probably just wrong. Get is empty. Set to array. Am I blind? Oh, it's add. It's add. So instead of pushing it to an array, we're adding it to the array. So a little bit different. And then again, we're just gonna new line these so you can see them. And this was the bullet closing, and this was the function closing. Okay, now we had some enemy stuff in here, and we don't have the enemy yet. So maybe let's just comment this stuff out for now. That has to do with the enemy, right? And then bullets.length. .length is a function, and I think it's get length in Java. I am wrong. Let's say dot, it's size in Java, not length. And then shift. Can we shift in Java? I believe we can. I may be wrong. Let's Google it. How about that? Let's open, I have a browser somewhere. It's not that one, it's this one. Shift array list Java. Built-in behavior of element moving during insertion mode or programmatic rotation of elements. We're adding all these things. Rotate. We can shift all of them to the right or shift them all to the left. I believe we were shifting them to the left, right? So, but then we would need to delete the last one. So what if, I know there's something called a DQ or a deck, and then we'll say shift in Java. Let's see if this works. So we can remove the first, which is what we want, or we can pop, which would be the last. So how about instead of an array list, we make a deck or a DQ, a DEQ like this, and this will be a DQ like that. And then we'll import it, and we cannot instantiate a DQ though. So it needs to be an array DQ. So let's do array DQ and fix our imports. Okay, that appears to be working now. So let's go back down. And we are... Did we make an error somewhere else? I don't think so. I think we commented out what I'm thinking of. Yeah, we did. Okay, we'll get back to that later. So we can remove first. And that appears to be the same thing as shifting it. Just to make sure. Original deck is that the pop. Using pop, which is equivalent to remove first. Then it would be just that. After we shift it, The removed element is the shifted element. Is that? Okay, I believe pull first. Hmm. Pop element would be banana. So what's the difference between pull first, pop, and remove first? Okay, just to make sure we don't forget this would be add last instead of just add. So just add that in there so we don't forget later. And then these all appear to do the same thing. We remove the first using pull first. It appears to do the same thing as remove first. So let's just do pop, because pop is something I'm more familiar with. That's either going to remove the first one in the list or the last one in the list. We'll find out. I think it'll work. We'll find out. And then we have that all good. So now, because we had to comment this out due to the enemy, how about we work on the enemy a bit? So we're going to make a new world object class, and we're going to call it enemy. And then we are going to go back to our reference, find enemy right here, and we're going to do a language conversion, just pasting this in here. And then this needs to be double. You can just copy this. I'm actually going to say public double so that we don't have to write public later. Public and public. And then let's see, we need to do equals instead of these colons. And not all of these are doubles, I don't think. Okay, this one is a Boolean. And we're going to end all of these in semicolons instead of commas. And then probably for the last time, we're going to make this into a, what's it called? A singleton. So private static enemy instance public static enemy get instance if instance is null, then instance equals new enemy enemy, and I am getting tired. Return instance. But we're almost done, so I'm not going to quit until we are done. Now we can access the enemy. It has all the properties that it needs to have. So I believe we can jump back to the bullet stuff now, because we have an enemy that we can get values of. So it was in game. We were talking about basically if we are on the side of an enemy, which direction we should shoot a bullet. And you can see add last is not errored, so that is the correct function to add to the end of the deck, or the DQ, whatever you want to call it. It's proper name, I think, is deck, but people don't understand what you say when you say deck, so it is what it is. So instead of enemy, we're going to say enemy dot get instance, and then this one was an X value. And I don't know why it keeps doing 2 G's when it's supposed to be an autocomplete, but we're gonna just replace enemy every time we see it. So now we don't have any errors in our bullet logic. We are making new bullets with the player's position and stuff and giving it a velocity depending on where we are in relation to the enemy, right? So I believe that this is pretty much all of our bullet logic, isn't it? Let's take a look at process bullets again. Yeah, that was all of the process bullet stuff. Now, the next time bullets are mentioned would be in collisions, and that's if we hit the enemy with them, right? So I think bullets are pretty much, they're pretty much fully implemented, right? So let's go look at that. We're gonna play, we can move around. If I push spacebar, nothing seems to be happening. That's because we're not drawing the bullets yet. We're not rendering them. So in order to render the bullets, that's why we made this DQ or deck, right? And we made it private. I think we'll make it public so that we can access it from elsewhere. We can already access the game as a instance, so this will give us access to this DQ or deck. So let's go back to our main panel where we're drawing things. Where did we draw bullets in this game? We did it pretty much last. Let's copy this, and we did it just before the grass. So grass will be the last thing. We'll put bullets in here, fix some indentation issues. Oh, these are all spaces. This is gonna drive me crazy. Oh my gosh, everything's all bleh. So this was part of a for each. That was indented. The for each is in if statement. Okay, I think we fixed it. So here we just raw said the fill style is brown. We could say this a little bit differently. Let's make it a bit more standard because we actually have a class for this now. Let's say public static color. Color is going to be color dot brown. There doesn't appear to be a brown color, so we might have to make one ourselves. Let's do orange maybe. Let's see what that looks like for now, and we'll import color to get rid of those lines with Control-Shift-O if you still don't remember how to do that. Now, if we go back to where we're rendering, then we can say instead of fill style, we're saying g.setColor. And then instead of just raw typing brown, we can say bullet.color because we made that statically available in the class. It's not just on instances of the class, it's part of the class itself. So we can just call it like this. And that gives us a real standard of everything's color is managed within the class of the thing that object is, right? So that's pretty chill. Enemy is not just enemy, it's enemy dot get instance. So anytime we call this, we need to say enemy, you know. So if the enemy is alive, it says it can't be resolved to a thing, and then it just went away, so that's cool. Okay, we have this for each function. Java has its own sort of thing for this stuff. So let's Google for each deck Java. And let's see if there's an easy one for us here. Okay, this will work. We can use an enhanced for loop. Sorry. I always call it an advanced for loop. It's not. We say for, we're going to say bullet, colon, right? I'm like staring at it and I still can't. Okay, bullet, colon, bullets. And then we're gonna open this like this, right? It appears. What's up, Senf? Welcome back. I think we're almost done remaking this game. We're just working out some of the last little things that we need to get through. It does say there is a for each that we can also use on this. So let's do that because it'll be more in line with what we wrote in JavaScript. So for each, and then we need to say like bullet. We're gonna make a lambda, which like I said before is similar to an arrow function. And then we need to put this stuff in here, right? And this is rendering stuff. That is huge though, man. We've only been streaming for almost 3 hours, which is less than it took for us to make it in HTML. But we are kind of copy pasting some things, which saves us some time. But we really are just converting it from one language to another. And I'm trying to show that it's really not that complicated to jump languages to do different things. So bullets can't be resolved. That's because we're in our main panel. We need to go to where our bullets are in order to get this list. So we need to say inside of game dot get instance dot bullets. Because we're getting the instance of game, we're getting bullets from that instance, and then we're looping through the bullets, right? So now we have bullet, which is going to be of type bullet, similar to how we wrote it over here. So bullet is a bullet, and then if the bullet's alive, then we're going to draw the bullet, right? So instead of can, we're going to say G, and then fillrect is mad because these are doubles instead of integers. So let's just fix that by casting them to integers. Boom, 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 boom. And just to stay somewhat consistent, we will break it up like that. Now it's not angry anymore. It should draw our bullets, right? So let's try that. All right, we fired a bullet and then we got some errors. So let's close the game and let's look at our errors. The ones that start all the way on the left are the beginning of our errors. We have a concurrent modification exception. What does that mean? That means if I am correct, that we are trying to modify the array at the same time we're trying to draw what's in the array. And because our drawing and processing threads are two different threads, they're competing for the same resources. So I believe if we just say in game, I believe there is a like synchronized keyword that we can use. Synchronized. Illegal modifier. Only public, protected, private, static, final, transient, and volatile are permitted. So, So what are we gonna do about this? This is one problem that I kind of saw coming, but I'm not quite sure how we want to fix this. That's cool, man. If you're tired, go to bed, man. I'll see you another time, Synth. Yeah, that's cool, man. I mean, you can always go back, watch a VOD, see how we finished, or like, yep, you've already seen the game before, so if you're not interested in the programming stuff, you already know what we're making, so I'll see you later, man. Okay, so let's Google a synchronized. Oh my gosh, Google. Oh my gosh, Google. Synchronized deck Java. In Java, thread-safe synchronized deck functionality is primarily provided by classes within the Java util concurrent package, specifically concurrent linked deck and linked blocking deck. Oh, interesting. That's nice, man. I'm glad you're here for me rather than whatever I'm streaming. It helps a lot when I'm like jumping around doing different stuff I want to do, whether it's playing games or programming or something. Like, I'm glad I kind of entertain you, man. It's kind of the goal here that I'm going for, you know? So, you stay safe too, man. Have a nice night. So, thread safe deck options in Java. You can make a concurrent linked deck. It's an unbounded, non-blocking, concurrent deck based on linked nodes. Or we can do a linked blocking deck based on linked nodes. For scenarios where an existing non-thread safe deck implementation like area deck needs to be made thread safe, you can use the utility method collections.synchronizedDeck, part of Google Guava's queues class. Not using Google Guava. The concept applies to using the standard Java Collections class if it were available. The standard Java Collections class does not provide synchronized deck methods directly, so one of the concurrent options from the concurrent package must be used. Okay, so let's try some of these concurrent ones and see if they'll do what we need. Let's make a concurrent linked deck. And that is going to be a new concurrent linked deck. Do we have other errors, or does that fix all of our problems? We will find out. We just need to fix imports. Let's try it. Let's just run it. It's working, and it's even cutting the last one we made, right? Which is exactly what we're going for. So this has fixed our problem. So because we are using 2 threads, we have to use our concurrent library in order to allow the 2 threads to essentially take turns looking at this list. And so that's what that's allowing us to do. And that's fantastic. That's a really quick fix. Thank you, Google. Now, our bullets aren't moving. That's something that I noticed. So let's go back here and figure out where our bullets are supposed to be moving. It's probably here. Yes. So let's copy this. It's in our update positions method. So process bullets, no. Process collisions, no. I think we just threw these in here instead of making another function called update positions. So where we jump and stuff. Yes. After right, it's here. It looks like. So let's make that function before we get too ahead of ourselves. So we have an update positions that's supposed to be right after this. And we are going to make that function. So private void update positions. I highly recommend copying and pasting your function names so that you don't spell them wrong. And then we need to cut this and this into here. Fix some indentation. We haven't fixed this yet, but the rest of it should work. After we updated the positions, we did the gravity stuff, and then we moved the player, and then processed collisions, and then we also need this if statement in here for the enemy. And once all of this is in here, our update function is finished. Isn't that crazy? Enemy.get instance, because we're converting it to our Java language. Boom, our update function is completely finished. Now we just need to fix all the things in the sub functions of it. So we know bullets we had to access a bit differently. Where did we do that? We did that in render, so I'm not gonna go to that. We'll say, actually we should be able to reach bullets, shouldn't we? Bullets. And then this is a lambda. That was the difference, is we needed to change it into a lambda instead of an arrow function. But that's perfect. That does exactly what we need it to, right? So now the bullets should move when we shoot them, and they do. And supposedly the enemy's over here is why we're shooting to the left and I can't shoot to the right. I think if we go over here, yeah, now we're shooting to the right. That's fantastic. I want a different color than the orange we picked. Something a little bit darker. So let's just try throwing some color values around. We know we're gonna need some red. How do you make brown? What is brown a mixture of? Brown is red, and the first suggestion was green. So we're gonna try some red, some green, and no blue. Let's try that. It's yellow. But how do we let's say brown in RGB and see what that gives us. Okay. All right, that sounds pretty decent. Let's try 150 and 75 and 0 and see what that looks like. Okay, that is brown. Is that the same brown we were using before? I'm not sure. Um, I kind of wanted a little bit lighter, if I had to guess. Let's try like 250 and 175. We know that's kind of the mixture we're going for. All right. That's a little bit more what we were looking for. Let's dial this back a little bit. We'll try 200. Maybe a bit more of that to like 25. Let's try lowering this to like 150. Okay, that's not too bad. That's kind of a brown color, and it's light enough that I can kind of see it, all that stuff. So cool, now we can shoot bullets. And it appears to be working as intended. So now we need something to shoot the bullets at, right? Well, technically we already have the enemy. So let's make sure we can see that enemy. We're gonna go to main panel. Where did we draw the enemy? We drew the enemy first, it looks like. So let's do that. This is where we drew the enemy. So before even the player, we're gonna say enemy. And again, we're gonna go to enemy instead of raw programming. Um, the color for it. Let's make a private static color, which is going to be color.red because the enemy is red, right? I don't know why it lowercase for me. That was kind of strange. We're going to go back to the main panel. It's g.setColor enemy.get instance dot color. Actually, it should just be enemy dot color. Did we not write? We made it private. It needs to be public in order for us to do that. Let's put that up here, just so it's a bit separate. All right, now we can access it, enemy dot color. So that should be a red color. And then we're just doing G. And then instead of enemy, it's enemy.getInstance, right? So let's replace all the enemies with getInstance. We kind of went off the screen here. Let's wrap it back down so we can see. Awesome. Now we're going to get the regular complaint that this is doubles instead of integers. I can't scroll left for some reason. Strange. So we're just going to cast these to integers. Same as we did with all the other things that we're drawing. Fantastic. There's no problems now. So if we run it, now we can see the enemy in the top left. I just pointed with my hand like an idiot. Now we can see the enemy on the left, which is awesome. This is exactly what we want. But the enemy's not moving. So let's figure out where the enemy moves. In update positions, we updated the enemy here. So let's go to update positions, and we did it after the bullets. And instead of enemy, it's enemy.getInstance, right? You're gonna get kind of tired of typing this. You might even want to change getInstance to be something shorter. I like getInstance because I just copy and paste it. I don't really care how long it is. Let's see if that moves the thing. It does move. However, it doesn't bounce like it's supposed to, which is a collision, right? So let's go look at our process collisions. We have the grass, we have the player. Here's the enemy collisions. So let's add this to our collisions, which is here. So we're gonna throw this in here, try and fix some of the indentation, which shouldn't take too long. And indent this, indent that. Instead of enemy, it's enemy.getInstance. Copy, replace, 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 replace. And then over here, we have grass.getInstance.y because it deleted the y. And then canvas offset width. Again, if we go look at player, the width was this long thing. So we're going to go here and replace this with that. And it wrapped, but it did replace this. So now, if we did that correct, it should bounce. And this is exactly how it does in the browser game we made. And we can shoot, but shooting the enemy doesn't do anything, and touching the enemy doesn't do anything. But before we worry about that, let's add some more things to the screen. Let's add our enemy health bar here and our other texts that we have, right? So we said in our rendering stuff, we said if the enemy's not alive, then we want to do this stuff. Otherwise, we want to do this stuff, right? So let's think about this for a second. And by that I mean take a big drink of coffee. We're gonna do a very similar thing here. We're gonna go to where we're drawing the enemy in the main panel, which would be, I can make this smaller again so it's easier to see where we are. It's here. So we said if the enemy .getInstance is alive, but if it's not alive, we wanted to do this thing, else we wanted to do this thing. So what was in if it is not alive? We wanted to write this text here. So we're just going to paste this in here. We'll fix it in a minute. Then we wanted to just draw the enemy, which is this code here. And then we wanted to do something after we drew the enemy, which was draw the enemy's health. So let's put that in here and do some language conversion. These will all be G, but we need to fix some things. Fill style is set color, right? Set color, and we said it was going to be green. And the font, we haven't seen this before. How you do font in Java is set font, and you're going to say new font. And this is where you say like Arial, and then the form of it is going to be like 0 regular, I think 1 is bold, 2 italic. This is what I was trying to do in JavaScript before we looked it up and figured out I'm an idiot. So, thank you for your follow, Albs63. I really appreciate it. We're trying to get affiliate, and that really helps out. Yeah, so we're gonna import font with Control-Shift-O, and then we're not done here. We also need the pixel size we're gonna do, right? So let's do 75. And this is how we set the font for our panel. So now that we have the font set, we want to fill text. I believe it's draw text. There might be a fill text too. Let me do a quick little Google. I think I closed my browser window. And I can't seem to open it again. Let's do this. And it's back. Let's say fill text Java. There is a fill text. So we will do that instead of draw text. We're saying you win at this position, this position. So the main problem it has is the position for the canvas. Well, we said the offset height. Once again, we're just going to go to player to get that. We're going to go here, copy this. We'll paste it in place here. And it's still having a problem. This fill text is undefined, string double. That's because this is a double, right? So let's make it into an integer and see if it's still mad. We have to surround all of this before we do the cast. It still seems to have a problem. The method fill text is undefined, so perhaps it is draw text or draw font or something along those lines. Let's take a look. We have clear, dispose, draw, all these things. And yes, you can draw images as well in Java. We will probably get around to that someday. It's drawString is what we're looking for. It's not text, it's a string is what we want. And yeah, so now that is working. We're gonna draw the text you win at 260 and then whatever this is, which should be somewhat close to the center of the screen. And that should work perfectly fine. Now for the health, similarly, we're going to replace this with g.setColor. And we're going to say color dot, I just forgot what color I deleted. So let's alt tab. It was black. So we're going to do black. And then we're going to set the font similar to what we did before. Is Arial. We said 24 pixels and it's bold. And then here it's enemy.getInstance. I just love how Eclipse helps me. What was this? .health. Thank you, Tyzel Ravens, for following me. I appreciate it. It really helps a lot. I am trying to get affiliate. So, you know, every step along the way, I think we're about halfway there now, aren't we? So that's pretty dope. Thanks a lot. We are going to do string, and it is drawString. We have the health, and then we just manually put in the numbers here. So all of this should be working now. So while the enemy is live, we see the health. And now we have this .0 because we're drawing a double here. So what if we cast it to an integer before we add it to the string? That should reasonably take off the .0, and it did. So that's nice. We have the enemy health now. We can still go around and fire and all that stuff. We need to be able to lower the enemy's health, which is when it collides with a bullet, right? So let's look at that. It was under collisions, bullet enemy. This is what we wrote for that. So let's go to our game. We're going to the collisions here. And this was the last thing before the last thing we need to insert. So we'll just put it at the bottom. Fix some indents. Boom, boom, boom. Boom, 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 boom. Boom, 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 boom. There's probably a faster way to do this. I don't know what the shortcut is, so here we are. Apologies. I will maybe learn. I'm not gonna make false promises. I'm not gonna learn before the next time I stream. So we need to indent this, and then these were all part of this if statement. And this was the inside of it. We said the difference between these two is arrow to lambda, so we know that's fixed. And then enemy was enemy dot get instance, right? And it just completely ignored me, which is awesome. So get instance, we are replacing enemy with enemy get instance. And everything else is fine. It doesn't seem anything is broken, right? So let's check it out. We're shooting the enemy and it's losing health. So that appears to be working properly. Let's go. Now we're not losing the game when we touch the enemy, which is kind of important, is it not? So let's add that in as well. We need to say when the enemy and player touch, this code is gonna run. So let's tab it in like this. Try and fix some of this indentation. That is really annoying. And let's do this. Up. Then all of this is in there. That's all part of the if statement. And these are the resolution of it. Okay, so enemy we know is enemy dot get instance. And then we can replace everywhere it says enemy with this. And that will fix those problems. Player, we know as player.getInstance. And I think that was X. It was. I don't know why it loves doing a strange replacement like that, but it does. So everywhere it says player, we're going to just paste player get instance, right? All right, cool. Now bullets equals empty. We need a way to empty our deck that we made instead of just saying equals this. One way we could do that is we could just make it a new array, because a new array would be empty, right? So perhaps we will do that. Let's say bullets equals new, And then I'm going to scroll up because I don't remember what this thing is called. Concurrent linked deck. Concurrent linked deck. And then we will do that. Okay, so that's essentially the same thing as make it into an empty array, right? So that should make it so when we touch the enemy, we no longer have bullets. We don't have the ability to make them. We don't have the ability to do anything. How about we look up a way to empty this instead of making a new one? So empty a concurrent linked deck Java. To empty it, use the clear method. That sounds pretty nice. So how about we just say bullets dot clear. That seems so much simpler than what we were doing. Let's click. Okay, when we touch it, it empties our bullets, and we can no longer shoot. I believe that's because we are no longer alive, technically. And when we push a button to shoot, the player has to be alive in order to shoot. So because we're not alive, we shouldn't be shooting anymore. So that is working correctly. It just doesn't look like it right now because we do have something in our main panel that we have not added yet, which is the player's if statements. We caught the enemy's if statement. Now we need to get the player's if statement. So let's check that out. In render, we had this if statement for player. So we're going to say if the player's not alive, if player get instance is alive but not, we're going to do this, else we're going to do this, right? So if we are alive, we just said we're going to draw the player. So we're going to cut this default draw stuff we had and just throw it in there. If he's not alive, we said we were going to put this text on the screen. So let's change these to G. We know this is draw string instead of fill text. We said this was set font. And then we said it was Arial bold at 50 pixels in size, right? And then fill style, we're setting the color to be color.brown, but we had to make our own brown color before, right? Let's copy this brown that we made for the bullet, and we'll try doing that color for this text. Okay, set font has some issues because it needs to be a new font like that. And then canvas offset height. If we go to player, we can grab that from here again and throw that right there. And then I see up here, I had to do this cast thing. That was on the health though. I think if we do an integer, it's not mad anymore, but I think we need to do it on all of this in order to be sure the position is going to be an integer. So that's cool. Now when we touch the enemy, we lose. And we can't even do anything, which is exactly what we wanted, right? Now, before we can test the game more, we need to make a way to reset the game in case I accidentally do that. Because I can easily like just avoid it like this, and we can try and play the game. Let's actually kill the enemy one time. Let's fully... Oh, I suck. So... if I keep sucking, we're never gonna find out what happens when the enemy dies, right? Let's make a quick reset button, which is it's part of our controls listener that we made, right? But we can't just reload the page. So what do we want to do when we push R instead of reloading the page? There's a couple answers to this. The quickest, safest, whatever answer is to essentially set all of the variables back to what they were supposed to be when you started the game. It's like we'll set the enemy alive, the player alive, we'll set their positions back to what they initially were. That's gonna be a lot though. The only things we really need to reset is in game get instance bullets. We need that to be empty, right? Because we shouldn't have fired any bullets yet. And then let's make a reset for the player and the enemy. We'll just make a function inside of these. Public reset. And this is going to be a void. So this is the only part that's really going to be significantly different. What does this go to? I think it automatically added that for me. Okay. So this is the only part that's going to be different from our HTML stuff because we have to make our own reset. Now we have the default values here. What if we just copied them all and we basically just paste them in here, remove all of the declaration words. I love this song. So we're just resetting everything back to what it's supposed to be. The color is never going to change. We don't need to worry about resetting that. The buttons we're pressing, I think we'll reset. Just so if you're still holding a button, when you push R, it's not actually going to do the action until you push the button again. But this should reset all of our values for the player. And then we're going to go into the enemy, and we're going to make its own public void reset. And again, we're just going to copy its default values, paste them in here, delete the declarations of them. And normally I'd say like this.x, this.y. I'm gonna not do that because I don't want to go, well, maybe I'll do it. I think I'll do it. I don't want to stray from my standards. So we'll say this dot, and we'll paste, 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 save. We'll go to player, paste, 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 paste. All right, pasted a whole bunch. Okay, so now we have a way we should be able to set all of the values back to what they originally were. And then I believe the game will adapt to that the way that it's written. Why don't we try it out? Let's go back to our controls listener, and we're gonna say player get instance dot reset and enemy dot get instance dot reset. So we're resetting the bullets, we're resetting the player, and we're resetting the enemy. The enemy should be the is alive stuff, the player should be the is alive stuff, which should affect how everything works. So let's try it. We died. I push R. It looks like it reset. Let's try shooting it a bit and then dying. And then pushing R. It looks like it reset. Okay. So we can die. We can reset the game. Now we just need to beat the game, right? We just need to make sure that we can win the game. And if we can win the game properly, then I believe we're done. So this could be a finished version of Cube Wars in Java. So we just got to keep shooting it. Oh, don't touch it. Oh, I got kind of close there. This might take a minute. Okay, let's go under. Let's try to go over. It's risky, but I like doing it. Okay, we're still shooting. This is gonna take a while, and it's supposed to, because the length of time that you're dodging it is what makes dodging it hard. Because you get impatient, you want to do cool things like jump over it, and you have to keep shooting it, so anytime you're not actually hitting it with bullets, we suck. Okay, here's what we're gonna do. We're gonna adjust the enemy's health to be lower. We're gonna set it to 10, and we'll make sure when it resets it to 10 as well in case I die. So now we shoot it. We won! We won the game because we only had to hit it 10 times. Now if I push R, it completely reset the game. We're good. We're completely good. So if I change these back to 5,000 and save the game, we have a fully functional Cube Wars game in Java that we converted ourselves from JavaScript and HTML to Java. And realistically, the code that we wrote was not very different, was it? Because we have our objects, the player, the bullet, the enemy, just pretty standard stuff. We just set some values in there. We have a controls listener, which has the key pressed and key released stuff. So that's the let's just run through this. We have the key press up and down stuff. That's in our controls listener, right? We have player, which is our player class. We have enemy, which is our enemy class. We have grass, which is our grass class. We have bullet, which is our bullet class. And then we have an update function. In this update function, we have our update function here that runs all of the sub functions that we made, which are all these like process bullets, process collisions, and then we have render here. And render is just our paint component method that does all of the same stuff written almost exactly the same way, right? So after render, we had update positions, part of the update stuff. We have tick, which isn't really a function. We could have put this inside of our set interval, but set interval is the only thing that was really a bit different, that we had to make our own inside of game. We had to make our own set interval function that used these current and past time and delta time things that are some timey-wimey nonsense bullshit, right? Where we're just managing the time in milliseconds it's been since the last time we updated the game, and then we're just going to repaint the game as often as we can, right? And that does exactly the same thing. We did this tick function every 60 seconds. So every 60 seconds, we were going to update the game and then render it. So this is another minor difference, is that we could put this in with this, and it would refresh both the visual and the logic 60 times per second. But because we have more power in Java, we decided to put it outside of the limitation, so it's just in a while loop, and it will draw as often as possible, possibly utilizing your graphics card if you have one. I wouldn't fully rely on that. It might use your processor, it might use your graphics card. We haven't specified what is being used to paint it. So just assume for the most part that it's going to be your processor. But my processor is really good and it can handle that really well. If your processor can't handle this, try putting it in with the update, and that will for sure work. I guarantee it. But if you can handle having it outside here, I would put it outside. That's just my opinion. But yeah, we've completely run through all of the code for Cube Wars, and we put it into Java, and now it's running as its own standalone program, right? That's really, really cool. Now you think, what if I want to share this game with my friends? Because a website you can host on like a web server or something like that, and they can just go to the web page and play the game. But in order to do this, would they have to install Eclipse and Java and all that stuff? Yes, they would have to install Java, and they would have to install a version that is the same or higher as what you configured as your I can't find it, but when you make a new project, right? We made a new Java project like this. You specified what version you wanted it to run in. Your friends will have to install this version that you specified or above. And so that's why a lot of people recommend doing 8 or 9, because most people have 8 or 9 or above. I would recommend, I think 11 is when we got lambdas, and we did use lambdas in this stream. Let's Google that. When were lambdas added to Java? Lambdas were Java 8, so I believe you could go all the way back to Java 8 when you make your project, and all of this should still work. So the only thing I'm concerned about is, when was the concurrent library added to Java? Oh, Java 5. So we're fucking fantastic. We're good. You should be able to go all the way back to 8. If 8 doesn't work, slowly go up to like 9, or like all the way up to like 11. I'm very confident it would work in 11. And most people just install the latest version whenever they get Java anyway. And a lot of people have Java these days anyway, because a lot of people play Minecraft. And you, at least originally, needed Java to play Minecraft. I don't know if they have a C++ or C# version or something of it now. I haven't played Minecraft in a very long time. But a lot of people do have Java now. And a lot of their programs probably already use Java. So you might not even need them to install Java, but they will need Java in order to play your Java game. And you might think like, well, that's annoying. Why don't I make it in like C# or C++ or something like that? Because C# you also need to install a runtime. You might already have it because you have Windows, but you will still also need a dependency for C#. And C++, if you were targeting like a Win32 window or something, then maybe you don't need a dependency. But if you're using something like SDL2, which is my preference at the moment, then you would still need them to install SDL2 or bundle it with your program in some way in order to have that dependency as well. So anyway, now that we've kind of cleared that, you will need your friend to have Java. If you want to export it from Eclipse in a way that your friends can play, I believe you can right-click, say export, go to Java, say runnable jar file. This is going to get, if you select it, the last build that you ran in Eclipse. So this is going to be the last Cube Wars game we ran. And then the export destination, this is where we want it to be exported, right? So let's go to desktop and we will just say Cube Wars. And it's going to export it as a jar. We're going to save. And then here, you can either you can extract required libraries into the jar, which you probably should do. We don't have any like dependencies or anything, so I don't think we need to worry about that. I think we're just going to say finish, and we'll see if that works. So now we've exported it. Here it is on our desktop where we made it, right? I'm just going to try double clicking it. It works. So on Windows, you should be able to just double click the jar and it will run this game. Isn't that awesome? You don't have to do anything in like the command line or anything like that. If you are, however, on, let's say, Linux or Mac, you might need to do something a bit different. You might have to open a terminal, and in the terminal, you're going to write Java, because you want the game to run in Java, right? You're going to say -jar. Why are we saying -jar? Why don't we just say Java and then the name of our program? Well, a jar file, if we go to like 7-zip, we can say open archive. And why would you open an archive? And why are there files inside of it if we open it as an archive? A jar file is basically the same thing as a zip folder. And I need you to think about that for a second, because when you look inside of a zip folder, you have to unzip that file first, right? So that's what we're doing here, is we're unzipping or we're unjarring this file to get what's inside of it. And then when we're inside of the file, then we can run what's been extracted from it, right? So we're going to say Cube Wars and we'll hit enter. Now we can play the game, and we launched it from a command line. So if we do close the command line, though, it's going to close the game, which is unfortunate from running things from a command line perspective. But if you're on Linux, you can look up NoHup. No, like NOHUP. It stands for no hang up. If you do a no hang up or NoHup command before you say Java -jar cubewars.jar, then you can close the terminal and you can still have the game open after you started running it. So yeah, that's how you convert a JavaScript HTML game into Java. It really wasn't that difficult. It only took us 3 and almost a half hours to do it. And then I showed you how to export your game from Eclipse to a jar, and then you would just send this jar to your friends and tell them, hey, I built the game using Java, I think it was like 17 or something we selected. You could probably say Java 8 if if you want to be really compatible. You say I made it with Java 8. So you need Java 8 or above in order to play the game. And so here's the file, just install Java, and as soon as Java's installed, all you have to do is double click my game, and now you can play my game. And then just explain to them, because we didn't, as part of our game design, step design an instructions menu or anything, tell them, hey, WASD is to move, like W is jump, and then A and D are left and right, spacebar is to shoot bullets, and then if you ever die or beat the game, oops, you can push R to reset the game, and that will save you time opening and closing the window and trying to fight with like focusing between different windows and all that stuff. And just say like, you know what, I want you to time how long it takes you to beat it, and then we can make like a scoreboard in Notepad or something. We can keep track of who's the best Cube Wars champion, you know? So that's that. We converted the game. Isn't that awesome? Let's see. Close my reference windows. I don't need them anymore. I will also be uploading this to the GitHub if you want to view the source code. I'm going to try to bundle the compiled jar in with it too, probably in like the root of it. So if you're looking to just play the game, then you can download it from there. It'll probably be under like a Java game development repo or something like that. I put all the other ones under an HTML JS repo. So if you're looking for it, that's where you'll find it. I think I'm actually gonna wrap up the stream. I kind of expected this to take longer than it did. I know that we already had the game developed before, so this isn't like... Oh, one thing I should say. If you resize the window... Okay, we'll fix that. Let's delete this because it's not going to have the code we want, right? Let's go back to Eclipse. And I closed Eclipse. Oops. The workspace is currently in use. Where? No, it's not. Oh. Okay. Never mind. Okay, so if you don't want them to resize the window, which is going to cause problems with the game, go to your main frame and say, after you pack it, say this dot resize. It's something along these. It's like resizable. Yeah, set resizable. Say false. That way, when they run the game, they can't grab the edges and resize it or maximize it. It is strictly 900 by 600, and they can't make it bigger or smaller. So that's going to solve a lot of issues with when your window gets bigger or smaller. And you can design your game around a stretching window. It's a bit more complicated. I don't really recommend it when you're first starting out. Also, Cube Wars didn't have a way to resize your canvas, so I didn't want you to be able to resize the window in this version either. We really wanted to get as close to Cube Wars in the browser as we possibly could. If we make something else, we will explore other options, okay? We can make like an internal resolution for our canvas, and then we can stretch that internal resolution to fit our JFrame window. And that's usually how you would solve that resizing issue. But yeah, there's a ton more games I want to make in both HTML, JavaScript, PHP even, and Java. We may explore C++ gaming. I honestly hate C#, so we will likely never touch that shit. I'm not doing Python, hate that shit too. So we're not doing that. We may involve Node at some point. I'm not very good at Node. I don't know a whole lot about Node, but I have used it before, and it's JavaScript. So we'll consider that. Now that we have Eclipse Enterprise for Java developers installed, which was free, by the way. None of this programming stuff costs you anything. All of this is free. We may also make some like JSP applications, which is Java server pages. It's like another way of hosting websites, but you can use Java instead of something like PHP. Yeah, like there's honestly so much stuff I can teach you guys. I can teach you how to make browser extensions, games, forms, like everything. Honestly, I don't have anything that I've ever not been able to make. So if you want to see me make something that you're interested in, or you have an idea that maybe you need some help with or something, just jump in chat. We'll talk about it. We'll see if we can get it cleared up, make it, If you want to make a game that has images, I'll show you how to make like an image loader and all that stuff for either HTML, JavaScript, or Java. Anything that you want to make a game in or have questions about, I will attempt to answer your questions. I'm not a professional game developer. I have not worked at a video game company, but I am a software engineer. So I know pretty much all the same stuff that a game developer knows, and that's how I made all this stuff. So we're just going to keep all this the same, and I'm actually going to close this now. I believe I'm done. I don't think there's any other outlying bugs we need to fix. But I think we'll beat this game one time, not get impatient, and when we beat the game, then we will wrap up the stream. But while I'm playing, I'm going to just slowly talk because I'm somewhat focused on the game. And I'm going to thank everyone that came today and dropped a follow. That really means a lot to me. We are working towards affiliate so that we can get paid to show people both how to make video games and how to play League of Legends well, because apparently no one knows how to do that. It's kind of an over-exaggeration, kind of a joke, but anyway, we do play League sometimes, and we may play other games as well whenever I feel like it. So, yeah, I want to thank everyone for coming, and hopefully this will be the winning run. If I lose, it will be very saddening. But yeah, like, especially Semph, I want to thank him for showing up pretty much every day that I stream. Oh shit, I almost fat fingered the jump button and died. Yeah, I'm trying to think what else I want to say before we wrap it up. It is one of my friend's birthdays today, so happy birthday to him. I hope things are going well for him at the moment. One of the reasons I was actually, I don't want to say later starting the stream today, but not exactly as early as I usually do it, is because he wanted to play some Magic the Gathering before I streamed. And I said, well, if you twist my wrist and give me the puppy dog eyes and beg, then I will pull out some magic cards and play with you. And so I did that. And that is why it took a minute to get to streaming. But here we are. And we are likely ending about the same time we normally do, because this language conversion of the game actually went a lot smoother than I expected it to, which is good. It's very good when things play out conveniently for you, you know? It's like you expect the worst and you appreciate the best, you know? So here we are, almost beating the game. Don't get complacent and fat finger the jump button while you're under the enemy. That would be very depressing. Okay, we're getting some damage in. We're less than 1,000. Don't choke. Don't choke. Okay. Alright. Get some more damage in. Almost there. I could be hitting it more than I am, but I really don't want to touch it. And I don't want to risk too much, you know? When we've already come so far. Do not want to mess this up. What was it going to get me? Oh, thank God. Okay. Almost done. We're almost at the victory screen. If there's a bug on the victory screen, I will also cry. But I think we tested that, so I think it should be good. 40. We're almost there. Boom. We won the game. We beat Cube Wars. Let's fucking go. Okay. So, again, thank everyone for coming. I really appreciate the follows. That means a lot to me. Yeah, we remade Cube Wars. If you're interested in more like language conversion stuff, we can try and make Search for a New Kingdom, I think is what we called it. We could remake that in Java. We could even try and make like a TUI in like C++. That would be interesting. Like non-graphical but somewhat graphical in console game. That would be interesting. Ugh, gotta burp. But yeah, there's tons of stuff we can do. I plan on just thinking about new game designs and just keep making new games that use different mechanics to show you all a bunch of different things you can do in game design and how you would implement it. I really want to have something with images in it, because we haven't done like an image loader and stuff yet, and I'm sure a lot of you are curious how you would go about that. So yeah, we will attempt to add images and audio as well. We'll probably find some copyright free audio to play as like some background music, and then we'll probably have like maybe some shoot noises or something if we're like shooting a gun, and we'll try and add those to a game too. I've done it before. I know how to do it, so it's not like we got to figure it out. I need to show you guys, and those things weren't included in the 2 games that I showed you. So, yeah. I'm gonna wrap it up here. If you're looking for the code and stuff, check out the GitHub. For like the 5th time, thanks for coming. I appreciate you all coming. I will probably be streaming tomorrow because I think tomorrow's Friday. Yeah, so I will probably be streaming tomorrow. I'm not sure what I'm streaming, but the plan is to stream. If something comes up, check my Twitter. If I'm like not streaming by like halfway through the day where I live, or like, when you're expecting me to be streaming or something, just check the Twitter, see if I've left a message there. I'll say if I'm like sick or, you know, like I just don't feel like it for the day. But yeah, for the most part, I stream Monday to Friday. If you want to come and see what I'm doing for the day, if I'm programming, maybe you'll learn some programming stuff. If I'm playing games, maybe you'll just chill and see what I do in the game. But yeah, thanks. Thanks. That's all I can say is thanks. I will see you all tomorrow. Bye. Have a good morning. Have a good afternoon. Have a good night, wherever you are in the world. I will see you tomorrow. Bye. Who is the sheet?